To wrap up our section on Java Synchronizer introduction, we're going to take a step back and discuss the usage considerations of the Java Synchronizer classes we've talked about so far. Now, keep in mind, some of this stuff is probably a little bit more than you need to know at this stage because you don't really have a lot of experience with the synchronizers, but I'm just going to give you, again, kind of an overview, which we'll refer back to later as we talk about other things. And one of the key things to always remember is that the trade-offs that often exist between performance and productivity. Performance is like how fast is something, how scalable is something, what the latency is. Productivity is how easy is it for people to do this correctly and have their code work. And there's sometimes trade-offs between those things. So some synchronizers or some methods in certain synchronizers have more overhead than others. So for example, spin locks, which will be your assignment 1B focus, are locks that cause a thread trying to acquire it to simply wait in a loop or spin while repeatedly checking if the lock is available. Conversely, there's sleep locks, and those are locks that don't return, they go to sleep, and they don't return until another thread has issued a notification that some event may have occurred. And there's some interesting trade-offs between these kinds of things. And there are trade-offs in micro level and macro level. So for example, spin locks are very efficient at a low level, but you can spin, which may be inefficient at a higher level. Conversely, sleep locks are inefficient at a low level because they go to sleep, but they may be more efficient at another level because they don't end up wasting CPU time unnecessarily. And in fact, there are actually things called adaptive locks, which are locks that'll spin for some time, checking to see if a resource is locked by a thread that's running. But if the thread that owns the lock goes to sleep, then the thread that's trying to get the lock will also sleep because there's no point in trying to wait for a lock if the owner is not able to run at the moment. So the key point with all this stuff is there's different amounts of overhead, and that overhead may be relevant at different levels of the system, depending on what you're doing. And we'll talk a lot more about that as you get through it. In fact, I would say one of the key things that you should get facile with as a result of this course is being able to evaluate the pros and cons of the different locking classes and different locking methods for your particular use case and application needs. And we'll talk a lot about that too. Some synchronizers are also harder to program correctly than others. So they may be very efficient, but they also may be error-prone and tedious to use. So here's an example. So non-reentrant locks are very efficient. They're more efficient than reentrant locks. And those of you who implement the grad student version of the assignment 1B will appreciate this because the grad student version is a little bit more complicated because it's reentrant. However, it's harder to program a non-reentrant lock because you have to be careful of self-deadlock. And we'll talk about self-deadlock in the context of object-oriented frameworks and callbacks and complex control flows. So you'll get exposed to that. I don't expect you to be facile with this topic yet, but that's just a preview of coming attractions. Java synchronizers, which are those dozen or so classes we talked about in the previous lesson, also differ from so-called Java built-in monitor objects. Here are some ways they differ. The built-in monitor objects are typically written in C and C++. I'll talk about what a built-in monitor object is in a second. But be aware they're written in C++ and C, whereas the synchronizers we talked about are typically written in Java with a little bit of calls to native methods in C and C++. And there's also, like I said, there's these low-level methods that use the very low-level features of the Java virtual machine. You don't actually get access to those things, but they're used internally for the most part. The Java synchronizers also provide many more features and have more powerful semantics than the built-in monitor objects. Built-in monitor objects, by the way, include things in Java like the synchronized keyword, which is used both on methods and on statements. That's a good example of a built-in monitor object feature. There's some other built-in monitor object features we'll talk about later, like the wait, notify, and notify all notification methods that are used in conjunction with synchronized statements and synchronized methods to implement monitor objects. So those features are very limited, very simple, whereas the synchronizers go above and beyond and do a lot more stuff. So that's the end of a very quick overview of this stuff. I'm probably not going to hold you responsible for knowing this in detail yet, because until you get access to really play around with the different synchronizers, it seems a bit abstract. But I just want you to get the big picture view that there's different types of these things. And once you get through with the course, you'll be in a much better position to know to pick and choose which ones are most appropriate for you.